Now let's continue with the next type of factoring, and that is factoring a perfect square trinomials. So for this type of factoring, we will be considering algebraic expression that has three terms. Okay, the first one is the first type of perfect square trinomial. But before that, when we see perfect square trinomial, that means there are three terms involved because of the trinomial. And the first term is perfect square, and the last term is also perfect square. Like for example, we have 4. And okay, so why is it considered again perfect square? Because usually the first term is perfect square and the last term is also perfect square. And trinomials, because there are three terms involved here: the first term, second term, and the third term. And for the perfect square trinomial, the first factor is also the same as the second factor. And for this, there are always two binomials involved as factors of a given trinomial. Okay, here, the first technique is that when you factor out perfect square trinomial, the first technique is that if the second term is plus and the last term is plus, all factors, the first binomial, the second binomial, the second term is positive, or the operation being used here is plus for the first factor and the second factor. And the same plus. Just like in previous examples, for this one, if trinomials, your two factors are all binomial. And for the perfect square trinomial, the first factor is the same as the second factor. For example here, you just have to distribute x. So x squared, that means there are 2x here involved. And distribute x for the first factor and x for the first factor in every binomial or quantity. And after that, you factor out 4. Okay, factor out 4 in such a way that when you add the factors of 4, the result is the coefficient of the middle term. And for the 4, the first possible factors are 4 times 1. And the second possible factors of 4 will be 2 times 2. Then after that, you add the first factors, that is 4 plus 1, the result is 5. And since 5 is not coinciding with the middle term here, the coefficient of the middle term, therefore, you need to disregard the first factors because these are not the required last term of your factors. And the second or the next option will be the factors of 4, which is 2, the product of 2 and itself, which is 2 also. And when you add 2 plus 2, that is exactly 4, which is exactly the coefficient of the middle term. Therefore, you consider 2 here as the last term of your factor. So that's it. When you factor out again plus the perfect square trinomial, the first binomial is the same as the second binomial. And you can rewrite this one into x plus 2, or the quantity of x plus 2 is the power of 2, or simply the square of the quantity of x plus 2. So again, this will only happen, the illustration of your factors, if these factors are factors of perfect square trinomial. Second will be, for example, you have here, one more example. I only have x squared plus 6x plus 9. Still trinomial. Okay, the first thing that you should consider so that it will be possibly a perfect square trinomial is you have to analyze the first term. If it is perfect square, obviously it is. And the last term is also perfect square. 9 can be rewritten into 3 raised to the power of 2. So therefore, perfect square. And this is just a partial basis for you to consider class that the given is really perfect square trinomial. And as I said earlier, that if it is perfect square trinomial, your two binomials as factors of the given are all the same. The first is the same as the second. Again, as I said earlier also, that if the operation of the second term between the first term and the second term is plus, or if the second term is positive, or plus in operation, as well as the third term is plus between the second term and last term, so all your factors here are plus also. And distribute, the next is distribute x in every quantity. And after that, in perfect square trinomial again plus, the last term here is also the same here. So therefore, the only factors of 9 that will give you the same number is only 3 times 3. And you use that one as the first, the last factor of the first binomial, and the last term of the first factor, and the second term of the second factor. So that's it. The factors of x squared plus 6x plus 9 are the product of x plus 3 and x plus 3, or simply the square of the quantity of x plus 3. You need this idea plus especially if or when you are solving quadratic equation by completing the square and other forms of solving quadratic equations that involve factoring. Okay, next example under the perfect square trinomial is this. I'll be using the same terms, but I'll be changing the operation, like x squared minus 6x plus 9. Obviously, class, based on the second example, this given is also perfect square trinomial, but we only change the operation in the second term, or between the first term and the second term. Okay, the same when you factor this trinomial, all factors are binomial. And since the operation here is minus between first term and second term, and plus for the plus as operation between 6x or between the second term and third term, this is what you should remember as part of the technique. If the second term is minus and the last term is plus, all your factors are minus between the first and the second term. And the same process as the next technique, you just have to distribute x in every quantity of your factors. And again, if it is perfect square trinomial, the last term here is also the same as the last term here. So therefore, the factor of 9, and that will give you the specific number here as the last term of your factors, the same number that will give you 9 when you multiply will be 3 times 3. So therefore, that is the first term, the first factor has the last term as 3, and the second factor the same as the last term is 3. And when you add 3 and 3 plus 3, the result is your coefficient in the middle term. That's the last way of checking that your factors here are the required factors of x squared minus 6x plus 9. The same here, that when you add 3 and 3 here, the result is 6, and that is exactly the coefficient of the middle term in second, as a second term of this trinomial. So therefore, that's another way of concluding that your perfect square, that the given x squared plus 6x plus 9 is really a perfect square trinomial. Or you may write this one into x x minus 3 and the square of x minus 3, or simply the square of the quantity of x minus 3 as factors of x squared minus 6x plus 9. Okay, so supposedly we have this last example for this perfect square trinomial factoring. Let us say, for example, we have x squared minus 10x plus 25. Again, partially plus, you consider x squared as perfect square, and if the last term is also perfect square, for you to partially conclude that the given trinomial is perfect square trinomial, and later after factoring, try to add the last term of your factors if it will give you the middle term, the coefficient of the middle term. Okay, let's proceed, class. So, again, the same technique. If the second term is minus and the last term is plus, all factors are minus. And distribute x in every quantity. Okay. And the factor of 25, the same. Again, as I said earlier, if it is perfect square trinomial, the last terms of your factors are the same. So, the factors of 25 that will give you the same number will be 5 times 5. And that is 5 here and also 5 here. So 5 times 5 or minus 5 times minus 5, that is plus 25 because their signs or operations are the same. And if you add negative 5 plus negative 5, the result is negative 10. So that is exactly the coefficient of the middle term. And if you multiply x times x, that is x squared. So these are some of the techniques that you can do to check that your factors are correct and to prove that your given trinomial is really perfect square trinomial because the resulting factors are to the same binomials. Or you may write this one into x minus 5 raised to the power of 2, or the square of the quantity of x minus 5. So that's it. I hope these examples class from 1 to 4 will help you to recall and remember and to refresh your knowledge about factoring a perfect square trinomial. Okay, so let's proceed as we continue with factoring. This time, let us talk about non-perfect square trinomial. How are you going to factor this type of trinomial? That's the question here. Okay, example we have here. X squared plus 3x plus 2, for example. This is an example of non-perfect square trinomial. Non-perfect, it is because even though the first term is perfect square, the last term is not perfect square, which is the partial way of checking or making a conclusion that the possible given trinomial is perfect square. But in this case, obviously 2 is not perfect square, so therefore you can easily say that the given x squared plus 3x plus 2 is not a perfect square trinomial. So how are you going to factor this one? Just simply plus, there are some techniques here that you can use to factor non-perfect square trinomials. The same that you have to do plus, if all operations are plus, simply your factors are all also plus in operation. And next, distribute x. And then, factor out 2, the last term. You get all possible factors of 2, that is only 2 times 1. That, when you add these two factors like 2 plus 1, the result is 3. And it should coincide or match the coefficient of the middle term. And when it happens, therefore you can say that your final complete factors of x squared plus 3x plus 2 are binomials or product of binomials, where the first one is x plus 2 and the second is x plus 1. Where did we get this 2 and 1? These are factors of 2 as the last term. And 2 as factors. Okay, and 2, the factors of 2 are 2 times 1 or 2 and 1. So simple as that class. Just try to follow and observe the different techniques and common techniques that we use to factor previous expressions. Another one. Supposedly we have this x squared minus, shall we say 3x plus 2. I am using the same terms plus, as you can see, but I am only changing the sign so that you can see the difference of their results. The same, that all factors are binomial. Next, remember that if the second term is minus and the last term is plus, all factors will be minus also. And the same technique as the next technique when you continue. Distribute x here as the first term of your factors. Then after that, get all the possible factors of 2. Since it is plus, automatic positive. And factor this 2 times 1. These are the only factors of 2. 2 and 1. And when you add 2 plus 1, still this will give you the coefficient of the middle term. So therefore, again, your factors here of x squared minus 3x plus 2 are the product of binomials x minus 2 times x minus 1, or the quantity of x minus 2 times the quantity of x minus 1. So, as you can see class, if you try to compare the first and second example, the terms are the same, only that in the second example, we change the operation here from plus to minus so that you can see the difference that if all terms are plus in second and last, all factors also are using plus. While if the second term is minus and the last term is plus, all factors here are using minus in the second term. And since these examples are non-perfect square trinomials, their resulting factors are not the same, but two different binomials the same as here and in the second example. While in the perfect square trinomial, all factors are the same here. That's one thing you should be vigilant about if you have observed the factors of perfect square and non-perfect square trinomial. Another one, supposedly you have x squared plus, shall we say, 5x minus 6. Okay, as you can see, I am trying to present trinomials here where the order of the operations are not the same. So this time for the third example, the middle is plus and the last term is minus. Okay, the order of operations here is different when you compare it to the second and the first example. However, again class, there are still some techniques that can be used. And the same, okay, if the middle term is plus and the last term is minus, I am suggesting do not put first the operation here. Just go directly by simply distributing x in every parenthesis or in every quantity. Then after that, try to get the factors of negative 6. Since it is now minus, when you factor out 6, you include minus as negative here. And then, get all the possible factors of negative 6. First, you will say, this will be negative 6 and 1, positive 1. Or you will say positive 6 and negative 1. Okay, so when you multiply negative 6 times 1, the result is negative 6. When you multiply positive 6 times negative 1, the result is still negative 6. And you may also consider positive 2 times negative 3 or negative 2 times positive 3. Okay, these are the different complete factors of negative 6. Then after that, you decide what should be the last term here in every binomials, including the operation, by simply adding the factors. And you may have negative 2 plus 3, the result is positive 1. Get your difference. And since 1 is not the same as the coefficient of the middle term, you disregard immediately that these factors are not the required factors that you need to use here. And then you proceed like 2 plus negative 3. Still, you are adding two unlike signs. The result is you have to get your difference, that is negative 1. And coefficient here is positive 5, so therefore you disregard this as the factors that you need for the last term. And after that, you add 6 plus negative 1. When you add two unlike signs again plus, you get their difference, and that is 5. See, that is positive 5. And that is exactly the middle term or the coefficient of the middle term. So therefore, class, you can now conclude that positive 6 and negative 1 are the needed factors of negative 6 for you to use as the last terms in every binomial here to complete your factors of x squared plus 5x minus 6. And to place these factors here, if it is positive, then automatic it will be plus 6. Or you may also say you can place plus 6 here. It doesn't matter. What is important is when you use 6, it is plus. And since it is negative, 1, since the sign is negative, automatic, when you place that one here, it becomes minus 1. Again, you can interchange negative 1 and plus 6. You may say that this will be x minus 1 and this one is x plus 6. It will not change the result that these are the complete factors of x squared plus 5x minus 6. So that's it. That's how you factor the third example under the non-perfect square trinomial factoring. You need one more? Okay, how about one more example for this non-perfect square trinomial? And supposedly we use the same given x squared, but this time instead of plus, we change that one into minus 5x and minus 6. What will be the result? That will be a question. As you can see, class, under the non-perfect square trinomial, I am trying to use the first example, the same terms, but the operations are changed. The same in number 3 and number 4 example. The purpose, one of the purpose here in class is for you to compare and to see their results when signs or operations are changed. Let's continue. The same factors, all are binomials. And for the third and fourth example, the same as what we did here. If the second term is minus, the last term is minus, I am suggesting that do not put first your operation between the first and second term, the same here. Just do it first by distributing x in every quantity. And after that, you get the factors of 6, although we have this already. You get the factors of negative 6, that is negative, the same as negative 6 times 1. And you have 6 times negative 1. Although you already have it, since you already have the idea here, you may not continue to present 2 and negative 3 and negative 2 and 3 as factors, because when you add these two different factors of negative 6 plus, as you can see, the result is negative 1 and 1, and it is very far from the middle term, which is from the coefficient of the middle term, which is negative 5. So this time, to save time plus, you only consider this negative 6 and 1 or positive 6 and negative 1. So when you add this negative 6 and positive 1, that is negative 6 plus 1, the result will be negative 5. As you can see, plus these factors, when you add negative 6 and positive 1, it gives you, the result gives you negative 5, which is exactly the coefficient of the middle term here. So therefore, you can now decide and conclude that negative 6 and positive 1 are the factors of that you need to complete as the last term here. So since it is negative, automatic, when you use that one, it becomes minus 6. And since it is positive, automatic, when you use that one, that is as 1. So therefore, plus the factors of negative 2, x squared minus 5x minus 6, the complete factors are the product of binomials, the quantity of x minus 6 times the quantity of x plus 1. Okay, so these are some of the 4 examples, the first 4 examples that I can give you, just for you to remember, to recall and refresh your knowledge about non-perfect square trinomial factoring. Okay, so I hope this will help you, class. And let's continue to the last type of factoring, which is the trial and error factoring. Let me erase this one first. For the trial and error, it is considered trial because you need to do some attempts, and the resulting factors may be not the required factor. That is why it is considered error, so trial and error, because there is possibility that the first attempt will not give you to the required factors that you need for that given trinomial. So trial and error factoring. You need several other attempts before you can get the required factors of that trinomial. Supposedly, in your given assignment, we will try to answer the first one. And that is 2x squared minus 5x minus 3. Here. Just try to see the techniques, class, because there are some techniques in our previous examples that can be used here, and try to see some more and observe, and later I'll be giving you the assignments, class, for you to practice what we have reviewed today. So that is why it is considered trial and error. In this type of trinomial, the first term is not perfect square, usually, and the last term is not perfect square also. It is considered again in class trial and error because of this way of factoring here, that you need, again, as I mentioned earlier, several attempts before you can find the required factors of this given trinomial. And since the given is still trinomial and it is quadratic, so you can still conclude that all your factors are binomial. And x squared is perfect square, and 2 is not perfect square as coefficient of x squared. That is why we also use trials, because this time, class, the first term, which has the variable of x squared, has a numerical coefficient this time, and this numerical coefficient is not perfect square. And this will give us the trial. And although, or since these two cannot be factored in terms of perfect square factoring, you can just simply, that 2, the factors of 2 is equal to 2 times 1. So you can just distribute that one here directly, and that is 1. And since your x squared is perfect square, that is equal to x times x, so you just have to distribute x. And again, class, if the numerical coefficient of variable is positive 1, automatically it should be removed or erased, because it is always understandable that it is always there even if it is not written. And after that, you get all the possible factors of the last term, which is negative 3. The possible factors are negative 3 and positive 1. The second is positive 3 times negative 1. These are the only factors, class, that you need to use when you try to get what are the factors of 2x squared minus 5x minus 3. Okay, this time, class, you cannot apply anymore the technique that we used previously, like when you say 3x plus 1. Do not do it at this time if we are factoring trinomials under trial and error, if the first term of the given has numerical coefficients, especially that coefficient is not perfect square trinomial. So the idea of addition here is not anymore applicable. So what will you do? is to try to use negative these factors as your factor, the last term here. You try, that is trial. And if the resulting factors give you the error one, then you change another one. That is why it is trial and error anyway. Supposedly, you try to use first negative 3 and positive 1. And maybe you place negative 3 here and 1. Since it is positive automatic, this one is plus. Okay. Next, what will you do is you are going to check for the middle term. The only way to check for the middle term class is this. You try to multiply the last term of the first binomial to the first term of the second binomial. When you multiply 3 times x, the result is 3x. And since this is technically minus times positive or negative times positive, the result is negative. Then after that, you multiply the first term of the first binomial to the last term of the second binomial. When you multiply 2 times 1, the result is 2. And when you multiply x times 1, the result is still x. Then after that, you add the result. Bring down x, and you are just adding negative 1 plus 2. So get their difference, that is negative 1. Again, plus, you can remove 1. And the result is negative x. So since the result is not the same as the middle term, therefore, class, you can conclude that negative 3, the 2x minus 3, and x plus 1 are not the factors of this given trinomial. Okay, so we have tried these first factors of negative 3. And this time, supposedly, you will try to use for the 2x, okay, this one, 2x, after using 2x minus 3 and x plus 1, supposedly this time, you are going to switch the last term or interchange. So this time will be 2x plus 1. You are done with x plus 1, so this time try 2x plus 1. And this time you are switching the last term. And you use negative 3 or minus 3 as the last term of the second binomial, which is, and this becomes x minus 3. This is your second attempt or second trial. The first one is here and the second is this one. The same class, you try to multiply the last term of the first binomial and the second term, the first term of the second binomial. Again, you try to multiply the last term of the first binomial to the first term of the second binomial, that is 1 times x, simply x. Plus and positive, so technically the same sign, so positive. Then after that, you multiply 2x times minus 3 or negative 3. So 2 times 3, that is 6. And positive times minus, that is automatically negative. And bring down x since there's no variable here. After that, add the result. So you have x, bring down x plus, and then technically there's 1 here. So 1 plus negative 6, the result is negative 5. You're almost, you got the right one plus the middle term, which is negative 5x. So therefore, after switching from the first trial class, we try to switch minus 3 and 1 here as the second factors, 2x plus 1 and x minus 3. The result, when we multiply the last term and the first term, and the first term and the last term, when we multiply the inner, the result is x, and the outer, when we multiply the outer terms, the result is negative 6x, and after that we add, the result is negative 5x. And it matches the middle term here, which is also minus 5x. So therefore, thus we can conclude that 2x plus 1 and x minus 3 are the required factors of the given binomial 2x squared minus 5x minus 3. So that's it. The final factors are 2x plus 1 and x minus 3. Okay, so just go over, just try to study the example, this example class again and again until you are able to master the process of factoring trinomials under the trial and error factoring. Okay, so I guess we will end up our review up to here. And for you to answer and to practice it, you really have able to understand everything. Your assignment, you can do this assignment class and submit this next meeting when we come back. The first, we have answered number 1 already, and your assignment will be the from 2, 3, 4, 5, and 6. You have 3x squared minus 10x minus 8, and you have 6x squared plus 11x plus 3, and you have 5x squared minus 3x minus 6, and you have x squared minus 4x minus 5, then you have x squared plus x minus 20. And the instruction is factor this given trinomials completely. Okay, so we will be seeing again next meeting, and I hope this review of factoring will help you facilitate your future mathematics lesson, especially involving polynomials, especially equations or solving variables in any algebraic equations, because the basic way of solving those variables is by using factoring method. If you think, class, that there are some examples here that you find it difficult to understand and remember, just go back and read and study it again. So thank you so much, and good afternoon.